your lab, we had a sample, like aluminum, and we took a beaker, a cup of water, and we found its mass. So let's just say this is 0.20 kilograms. We found the mass of the sample, or 0.058 kilograms maybe. Your numbers will be different. We measured the temperature of the water initial, and that was somewhere around maybe like 18.0 degrees Celsius. The sample was in the boiling water, so it's going to start off at 100 degrees Celsius. Whoops. In our spreadsheet, we need to put our units up in the title, not in the cells with the numbers, or you won't be able to do calculations with them. You then stuck the hot sample into the cold water, and you measured the final temperature, and most of you were surprised to figure out that the water didn't heat up a whole lot, and the aluminum cooled down a lot. And your job is to find the heat capacity of the sample from all of this, okay? So you can do it a couple of ways, but the easiest way is to use our formula. So our formula says that the heat that is gained, Q gained, plus the heat that is lost, have got to add up to 0. And you can do this in a couple of steps. You could find the heat that is gained by the water. So make an extra table, an extra column here. Take the mass of the water times the heat capacity of water, which is 4,186 joules per kilogram degree Celsius, and multiply that by the change in temperature of the water, which will be T final minus T initial of the water. So you can find the Q that is gained. Then you can find the Q that is lost because they're equal but opposite signs. But it's easier just to solve it algebraically. So what gains heat is the water. So we're going to have the mass of the water, heat capacity of water, times the temperature final minus the temperature of the water initial. And those are all things you have up here. Plus the mass of the sample, I'll call that X, times the heat capacity of the sample, times the change in temperature of the sample, which is T final minus temperature of X initial. And all that has to equal 0. And so all we're trying to do is solve for the heat capacity of the sample. All right? So we have everything else. We have the mass of the water. It's right there. We have the heat capacity of water. We have the final temperature of both. We have the temperature initial of the water. We have the mass of the unknown sample. We have temperature final, because they're both the same. And we have the temperature initial of the sample. So the only thing we don't know is the heat capacity of the sample, the unknown. So you just need to solve for that. So if you bring this term to the other side of the equal sign, you get mass of X times C of X times temperature final minus temperature of X initial equals minus the mass of the water, heat capacity of water times temperature final minus the temperature of the water initial. And if you want to find the heat capacity of the unknown, you're going to divide both sides by the mass of X times this difference in temperature. So if we do that to both sides, I'm going to have the mass of X times the temperature final minus the temperature of X initial. And so that leaves over here the heat capacity. So to find the heat capacity, you just have to write a formula here which calculates this. You take negative times the mass of the water times 4,186 times, open parentheses, the final temperature minus the initial temperature of the water, end parentheses, divided by, and make sure you group your denominator. Calculate that, check it on your calculator to make sure it's right, and once you know your formula is right, you can copy your formula down to do the calculations for all of the samples that you were able to get to. Okay, I know you didn't get to all of them. You should have at least 3, and so there should be 3 calculations here. And you can check one of those with your calculator to make sure your formula is right before you actually copy it down to the rest. Okay, so that's how you finish up your lab. Then turn in the link to the spreadsheet.